So we're picking up with a discussion of how individual oxygen atoms covalently bond together to form a diatomic oxygen molecule. We talked about how orbital overlap occurs, but in order to achieve the octet rule, we're not sharing just one electron pair between two oxygen atoms, we're sharing two. Simplifying this picture, it's easier to write oxygen as a diatomic molecule showing two covalent bonds between the oxygen atoms, a sharing of two electron pairs. We call this a double covalent bond. A double covalent bond, sharing of two electron pairs, and then of course we have the unshared or lone electron pairs around each of the oxygens as well. So as you look at this structure, you can see that each individual oxygen atom has an octet. A circle around this first oxygen, counting 2, 4, each line 2 electrons, 2, 4, 6, 8 for the first oxygen atom, and then an octet around the second oxygen atom as well, counting, showing a circle here, 2, 4, 6, 8. So let's take those ideas and apply them now to the formation of diatomic nitrogen from nitrogen atoms. Looking at nitrogen, we see that it is in family 5A. It has 5 valence electrons. Drawing a Lewis dot structure for nitrogen showing those 5 electrons, I see that, I might need to redraw this to better illustrate the bonding that will happen, because nitrogen's 5 valence electrons means that it will have to share 3 electrons in order to have an octet. 5 plus 3 is 8. So I'm going to shift this 1 electron and line it up with the other 2 in preparation for 3 electrons being shared. So I'm drawing the Lewis dot structure in this manner. That's totally fine, as long as you have the correct number of electrons showing around the atom, valence electrons that is, and you're using the points of the compass. And here is our second nitrogen atom. Again, 5 valence electrons, lining these electrons up so that I see that 3 electron pairs are going to be shared. So that gives us this drawing where we are showing a triple covalent bond around or between the 2 nitrogen atoms. So looking at our drawing a circle around the first nitrogen atom to see how many electrons are there. Is it an octet? We see that yes it is, 2, 4, 6, 8 electrons around the first nitrogen atom, and the second nitrogen atom also has 8 electrons in its circle, and we can simplify this and draw diatomic nitrogen showing a triple covalent bond holding the 2 nitrogen atoms together. Each nitrogen has its lone electron pair, 1 lone electron pair. So we have a total of 8 valence electrons around each of the nitrogens. 8 valence electrons, and we are looking at a triple covalent bond. So the important point as you move forward with drawing Lewis dot structures for molecules is that the structure should show every atom having an octet between the shared electron pairs and any lone electron pairs that may be present. The only atoms that would not have an octet would be, of course, hydrogen, which follows the duet rule, and helium, but we do not see helium in compounds. It's a noble gas and unreactive. One last thing before we finish this discussion is once we see the Lewis dot structure, it gives us an idea or information about why nitrogen as a diatomic molecule is less reactive than oxygen is. Both nitrogen and oxygen are present in the atmosphere, but nitrogen a much more unreactive gas compared to oxygen, and the bonding structure explains why. In order for nitrogen to react, we would have to break a triple covalent bond in this molecule as a reactant. And that bond is a stronger bond because there are a greater number of electrons being shared. So it's going to be harder to break that triple covalent bond holding nitrogen atoms together than it would be to break the double covalent bond holding oxygen atoms together. So oxygen, a more reactive molecule than nitrogen, precisely because of the bonding that is present in the molecule.